Good afternoon, SYBC students. Let me introduce myself. I am Professor Smita Mangesh Junnerkar. Hope everyone is safe at home. Student, I know this is a very hard and difficult time, but believe in God's. Okay, students. Today we will start with the computer architecture and organization topic. Let's start with our section. Machine introduction and addressing mode. Machine instruction is an instruction or a statement that directs the computer to perform the required data processing task. It is also called as a list of instructions for directing the computer to perform a desired data processing task to forms a machine language programs. Let's move towards the different types of machine instructions. They are as follows. Role of instruction. Now over here, load and stored instruction, arithmetic and logical instruction, test and branch instruction, input and output instruction. Second, classification of machine instruction is size of instruction. Those are 1 byte instruction, 2 byte instruction and 3 byte instruction. And the third one, that is addressing modes. Addressing modes are implied or implicit addressing modes. The operand is not specified. The location of operand is implicit. Next point is the immediate addressing modes. The operand is specified in the instruction itself. Third one, that is a direct, or it also called as an absolute addressing mode. The operand is in the memory and the address of operand is specified in the instruction. Fourth one, that is a register direct addressing modes. The operands are held in the register which are specified in the instruction. Register indirect addressing modes. The operands are held in the memory. The address of memory location is held in the register which is specified in the instruction. These all are the addressing modes. Now over here, few more addressing modes such as displacement. It is similar to register indirect addressing modes except that an offset is held in the instruction that is added to the content of register specified in the instructions to form a effective address of the operand. Base index addressing modes. This addressing mode is similar to displacement addressing mode except that an offset is present in index register that is specified in the instruction. The effective address of the operand is computed by adding the offset retrieved from the index register to base retrieved from the base register. Now let's see over here microprocessor operations and register transfer language. The basic operation that can be performed on the data stored in the register are known as a micro operation. The common examples of micro operations are shift, load, clear and rotate. These micro operations are triggered by clock pulse and occurs at regular interval within the computer system. The number of lines in the bus would be k, that is equal to those numbers of bits in the each register. Now, the number of multiplexer required would be k, that is equal to number of bits in each register of equal to number of lines in the bus. So, when you student, number of bits in each register is supposed to be equal to number of lines in those bus. That is called as a micro operation. The size of each multiplexer is equal to nx. 1. That is, multiplexers select one register out of n. There are multiple things, and within that we have to select only one register. Since each multiplexer of size n multiplied by 1, the number of select lines required is equal to log n. Both MAR and MDR registers are connected to internal bus. Multiplications and divisions are not included as micro operations. Multi, uh, Multiplication is the implemented as a sequence of add and shift micro operations, and division is implemented as a sequence of subtraction and shift micro operations. Now let's move towards the next topic, that is a control design. There are two approaches to implement the control unit. First one is a hardware control unit and second one is a microprogram control unit. Let's focus on the first point, that is a hardwired control unit. This forms of control unit is implemented with gates, flip-flop, decoder and other digital circuits. Its performance is superior as compared to microprogram control unit. If the instruction set of the machine is modified or changed, the control unit needs to be rewired. Now let's move towards the second point of control unit, that is a microprogram. These are stored in the special memory. It is also known as control store or control memory. Micro instruction consists of sequence of control boards corresponding to the control sequence of a machine instruction. The simple encoding schema in which each control signal is represented by a bit in micro instruction is known as horizontal microprogramming. The high encoding schemes in which compact codes are used to specify only a small numbers of control functions in each micro instructions is known as vertical microprogramming. Horizontal microprograms control unit has a higher performance as compared to vertical microprogram control unit, as a decoding is not required. Now let's move towards the next option, that is a instructional pipeline. Pipeline is a concept used in the modern computer to achieve the higher performance. The number of steps of an instruction varies with the architecture of the machine on which it is executed. Pipeline increases the CPU instruction throughput by executing the multiple steps in the parallel. The CPU instruction is defined as the number of instructions completed per unit time. The CPU instructions throughput is defined as a number of instructions completed per unit time. Pipelining does not reduce the execution time of an individual instruction. It does not reduce the instruction latency, that is, the time to complete a single instruction from start to end. Now let's move towards the hazards of pipelining. Any condition that causes a pipeline to stop is known as pipelining hazards. There are three classes of hazards: data hazard, control hazard, and structural hazard. Let's see first one, that is a data hazard. It is a condition in which the source or the destination operands of the instructions are not available at the expected time. Second one, that is a control hazard. It is a condition in which the instruction is not available in the pipeline at the expected time. And the third one, structural hazard. It is a condition in which two or more instructions require the use of given hardware resource at a time. Now, main memory and cache memory. The memory unit that communicates directly with the CPU is known as a main memory. It is made up of semiconductor. It consists of RAM and ROM. Static RAM has a shorter read-write cycles. It is a faster than dynamic RAM. However, the static RAM cell takes more space on chip than dynamic RAM cell. Therefore, it has lesser memory capacity available per chip as compared to dynamic RAM. Thus, the static RAM is a cost as compared to the dynamic RAM. Static RAM is used to create for creating the cache memories, and dynamic RAMs are used creating the larger RAM spaces. The RAM chip of size is n multiplied by k required logs to n addresses line and k data lines. The RAM chip has a read signal and the write signal. The ROM chip is similar to RAM chip with a difference that does not have RD and WR signals because it can only be read. Now let's move towards the associative memory or content addressable memory. It is used in very high speed searching application. It searches all memory words in parallel in a single one operation. Now cache memory, it is a fast small memory that is allocated between the CPU and the main memory. Next point, data access also exhibited locality of reference not as strong as exhibited by code accesses. A widely held thumb rule known as 1910 rules stated that the computer program spends 90% of time in 10% of its code. The performance of cache memory is measured in the term of hit ratio. The advantages of associative mapping is that any word from the main memory can be placed anywhere in the cache memory. It can be appear at node. It directs the mapping to memory words with the same index but different tags cannot appear at the same time in the cache memory. One way set associative memory is direct map cache memory. Since the set size in the set associative mapping increases, the hit ratio improves. The main memory block is the first map onto a set and then the block can be placed anywhere with the set. Thank you students. I hope this point is clear to you. Please revise at home and if you are having any query, let me know.